Welcome to the Crazy Hat Chemist. So another video in solutions and their behaviors. Bam! So today we're calculating concentrations and we're going to be doing the mole fraction here. So I'm going to read the question here. It says determine the mole fraction, the molality, and the weight percentage if you have 142 grams of ethylene glycol. That formula is C2H6O2 is dissolved in 250 with a decimal grams of water. Okay, so I'm going to divide this video up into a number of different, or this problem up into a number of different videos. I got one video here right now on mole fraction. Okay, so let's get moving on this. This is the formula, or the structure rather, of ethylene glycol. Okay, so if you're not familiar with ethylene glycol is an antifreeze. Okay, and that would go inside your radiator of your car. That is to prevent the radiator or the water that's in there from freezing by adding ethylene glycol to it. Okay, it's also to prevent it from boiling over on a really hot day, both examples. Okay, all right, so the first thing that we're going to do, if we're going to get the mole fraction, we need to get the moles of the ethylene glycol and the moles of the water. So here is determining the moles of the ethylene glycol. So I got 142 grams of ethylene glycol. I'm going to use the molar mass for ethylene glycol. That's the 62.067 grams. That's equal to 1 mole. And that gives me 2.29 moles of ethylene glycol. Now I'm also going to get the moles of water using that 250 grams. Notice that there's a decimal at the end of that 250. That lets me know that that trailing zero counts, because that is a trailing zero with a decimal in the number. That trailing zero counts when determining significant figures. So that's 250 grams. Then the molar mass of water is 18.015 grams. That's equal to 1 mole. And I got 13.9 moles of water. Now I'm going to get the mole fraction of both the ethylene glycol and the mole fraction of the water. Okay, so here is the mole fraction of the ethylene glycol. I got the moles of ethylene glycol in the numerator. That's the 2.29 moles of ethylene glycol. Then the denominator has the total number of moles. This is a two-component system. It has ethylene glycol and water in it. So I'm going to have the moles of ethylene glycol in the denominator. That's 2.29. And then the moles of the water in the denominator. That's the 13.9. I'm going to sum those numbers up, then do the simple little division, and I'm going to get my number here. Then I'm going to get the mole fraction of water. The mole fraction of water is going to take the moles of water, that's the 13.9 moles of water, divided by the total number of moles. Now again, it's the 2.29 moles of ethylene glycol and the 13.9 moles of water. I'm going to get the mole fraction of ethylene glycol here. That's 0.141. There are no units to this number because the moles cancel out. Okay, and you're left with just a mole fraction. It's not a mole percentage. We're not multiplying this by 100, so that means that all these values are going to be less than 1. If you get any number for a mole fraction that is greater than 1, then that is a problem right away. Then here is the mole fraction of the water. Now I want you to think about these two numbers and what these two numbers should sum up to be. Okay, so there's only a two-component system. So the mole fraction of ethylene glycol plus the mole fraction of water should sum up to 1. So I recommend that you get the mole fraction of ethylene glycol, then get the mole fraction of water. Then you're going to take one of these and plug it into this equation on the right-hand side so that you can figure out and kind of like check your work and solve for the other mole fraction, since they must sum up to 1. You've gotten them individually first of all, and now we're going to use the mole fraction of the ethylene glycol. You could have used the mole fraction of water and then solve for the mole fraction of the water. But here, I'm going to solve for the mole fraction of the water here and not for the ethylene glycol, and it's 0.859, and that corresponds to what I solve for by plugging in the numbers in total. Remember, if it's equal to 1, then you're always going to get the other number by default, and hopefully you've done the first one correct. But if you've done the first one correct, then get the second one. They should sum up to 1. If they sum up to 1, then that's your check, and that way you know you got the right answer. Okay, that's another cool Crazy Hat video by the Crazy Hat Chemist, and I am I'm bear about chemistry. I'm Bear About Chemistry. So if you like that video, give me a thumbs up, subscribe to my YouTube channel, please pass it on to all your cool chemistry friends. I'm going to see you next time for more cool chemistry videos. Bye now.